Okay, this video is designed to give you a little bit of help with the orthographic projection that you've been asked to produce as part of your final design work in your resistant materials coursework. Let's just remind ourselves of the three-dimensional drawing that we're trying to convert into an orthographic drawing. Now, your teacher's probably mentioned to you that we've got a 3D drawing, but we actually need to convert that into a series of two-dimensional views. Now that means that we're going to be concentrating on the information just on the front, then the information on the side and the information on the top. But we're going to separate that off into a series of 2D drawings rather than containing it all in this one 3D drawing. So to do this, you're going to need this as a starting point, because actually you're going to need to know all of the dimensions. So the drawing that you're going to do, the orthographic projection that you're going to do, is actually going to be to scale. Now, in relation to scale, you'll notice that I put on my page here that actually I'm drawing at scale 1 to 2. Now, some people get a little bit confused about this, so let's look at this little grid that I've drawn, which goes some way to explain that. Scale 1 to 1 is actual size, is life size. Okay. Now in my product, I have the length of mine, 175. If we go back to this, you'll see 175 is the length there. I've put a plus 20 because actually the overall length is made slightly wider because we've got this controller sticking out the side. The width of my product is 70 and then the height is 220. So you can see all those dimensions on there, and these ones are very much starting points for getting your drawing laid out, but you will need other dimensions such as you'll notice that I've put the radius of this large circle on here because obviously we're going to be setting a compass and needing to know how big that circle is. Okay, let's look at our converting chart though. All I've done here to create this 1 to 2, which you'll notice looks a little bit like this fraction meaning half, which is exactly right. This is a half size drawing. We've got 175 divided by 2 is obviously 87.5, 20 divided by 2 is 10, and so on. So this set of dimensions are the ones that I'm working to in order that my drawing actually fits on the page. So if I'd have done it 1 to 1, I wouldn't have actually managed, 220 was the height, the height would have taken up that much, and then obviously I wouldn't have had enough room for the other parts of my drawing. Now, just to explain, this little drawing here in the corner gives you an idea of how we set out this series of two-dimensional drawings. We're going to be drawing a front view, a plan view, and an end or a side view, and they must be drawn in this arrangement around this cross. So in this quarter you'll see that there's a 45-degree line. This quarter we're going to be drawing our plan, this quarter we've got our front view, and this quarter we've got our side or end view. Okay, now the first thing you're going to do within your drawing, and I put some lines on here already but I will explain, is to start off with this cross. Now what I've done is I've drawn a double thickness cross that's got 10 millimeters between it. That's why I put these little 10s in here. So I've drawn two vertical lines 10 mil apart, two horizontal lines 10 mil apart, and they cross in the middle. You've got this box here, and then I've put a 45-degree line in that quarter, which is exactly like this little drawing here. The purpose of the 10 mil gap is so that our drawings, our front view and our plan view for example, aren't actually touching on this line. So I want them to be separated 10 mil apart, and similarly I don't want the front and the end drawings touching either, so we put this 10 mil here. Okay, so when you're setting up your drawing, you're always going to be setting it up with that cross first off and your 45-degree line. Now the next thing you do is to create boxes for your drawings to go into, and these boxes have to be matching with the overall length and overall height if you're drawing your front view, the overall length and the overall width for your plan view, and then the overall height and the overall width when you're drawing your end view. So we're going to be drawing a series of boxes in here that match those overall dimensions. Let's come back to our little grid here. So for example, we're drawing our front view first within this quarter, all of our dimensions are measured from this point here, from the bottom end of that square. And we're going to be measuring out the length, 87.5 plus 10, which obviously is 97.5. We're going to be coming across, and then we're going to be putting a dot on our line and then drawing in a vertical line. And actually you're going to be leaving that nice and faint and we're going to be filling in later with a darker line those things that we want to see. Okay, that gives us our length. We now need to put in the height of that, which is obviously 110, and again we're going to be measuring from this quarter down 110 and then drawing that line across. And the line goes right across the drawing. Okay, then do the same repeated thing, drawing a box in for your plan view, but actually this one you measure from that corner, so the corner that's closest to where that drawing is going to be. That dimension is already drawn in for us because we projected that line up. This dimension we need to measure in, and we know it's 35mm, so we'd simply match up that corner 35, put a dot, come across. The purpose of our 45-degree line suddenly is seen in that when lines cross the 45, we then have to bounce them down at 90 degrees, like this line here. Now that means that actually this box draws itself and we don't need to do any measuring. We've done everything properly within these two boxes. Actually this drawing will draw itself. Now the idea of projection is obviously how orthographic projection gets its name, because we're transferring information from one place to another in the same way that a projector would in a classroom. Okay, I've got my box here, so I'm now going to start to put in some details. So I've got, as I've said, this controller that sticks out the side 20mm. Now we've changed that so that obviously we're doing it scale 1 to 2, which means it's sticking out 10mm. So I'm going to put in a 10mm line that runs up the side here, nice and faintly, and you'll notice that I'm transferring this information from my front view right up to where my plan view is going to be drawn here. Okay. Now I know that, to go back to my drawing, that actually that controller is 30mm from the bottom edge here. So I'm going to convert that again, divide that by 2. I'm going to come back and I'm going to be putting in a line at 15mm. And again I'm going to be drawing that across my drawing, because that information is going to be needed when I'm drawing the end view, like that. And I know that my controller has a radius of 20mm, sorry, a diameter of 20mm, so we need to divide that down to 10, and we're going to be putting in that again on here, transferring that information right across. Okay, so that at the moment is the side view of my controller, that bit there. Right, within this big space obviously I've got to draw my front view. Now this has on it a radius, and I know that we're going to have to be using a compass here. We've got to set our compass with the right measurement, the right diameter, to get that curve in at the top. My hand stopped shaking for a minute. Now this one, it's got to be 44. So I take my compass, place it on my drawing, and then I'm going to be drawing in that arc. Like that, gives me the top. I'm going to use the same point obviously for that central circle, because that runs inside there as well. And that one's 30, 35. So again I'm going to use my ruler, put that in the same hole, and then repeat that circle round. like that. Okay, so what we've got now within this set of drawings is, or set of lines, we've got the front view here with my circle in here, and we've got the controller on the side, and that's effectively all we'd see. We do need to put in the night tick that obviously runs across the front of that, so I'm very lightly going to put that in. Like that. As I say, you're going to come back and you're going to put certain lines in much heavier at the end of the drawing. Okay, let's look at the top view now. If we're looking down on the product, all we're actually going to see is pretty much that. We're looking down on here, we can't see anything apart from that, although we would see this poking out the side. So when we're looking down on this, it's just going to be that controller and actually pretty much a rectangle that we're going to see, because in 2 dimensions you don't see a curve. When you're looking down on the top of it, look down on top of this, it just looks like a rectangle. Yeah? We can see the curve when we're looking at the front, but actually if you're just concentrating on that top view, all you can see is that section there, which just looks like a rectangle. So our rectangle's drawn for us. All we need to do is put in that information for the controller. We know that it's got a 10mm diameter because we've drawn that in there. So we're going to transfer that information onto here the same way. That's that point there. So if I put 2 dots and then transfer that line right across our drawing again, because we're going to use that information to place that on our end view. You'll see how that happens. Okay, so my lines come across to 45. We've got the controller drawn in there now. So we're looking down on the top. That's the controller standing outside. Where we've got lines hitting our 45, we then transfer those down our drawing, and you'll see that they'll cross over with the lines that we already transferred across from our front view. So we've got this space here is where then that controller would be placed. I'm going to draw it in freehand, but you'd obviously use a compass for that. So when we're looking at the side of our product, like that, see I've penciled in this line here, that's where the controller would be. Again, it just looks like a rectangle because you're not seeing any depth. All you're seeing is a 2-dimensional view, and you've got that controller on the side seen on the end. So that's how it would look. Now at this point I'm kind of happy with that, so I can then go back and actually put lines in much heavier. So I'm only interested when I'm looking at my end view in seeing the box, not all of the lines that are crossing it. Sometimes you're doing quite a difficult drawing, there's lots of lines and it can become quite confusing, so it's quite nice to come back in then with a slightly heavier pencil and pick out just the lines you want to see. Like I said, I'm going to do this freehand, but you make sure you did that properly with a compass. So similar on the top then, only the lines that we actually want to see. You wouldn't ever rub out the other lines because actually the examiner likes to see that you've constructed your drawing properly. And it's a little bit like in maths, making sure that you show you're working out, because you should have used the 45-degree line and the projection idea. So that's what the top is going to look like. And we're looking down on the top with the controller stuck out the side, and then our front view is going to look as you would expect. Now I haven't got heavier lead to put in my compass, so I'm going to have to fill this in freehand, but you've probably got compasses that you can put different pencils in. So that line there wants to be heavy so that we can see it. That's the controller sticking out the side. I'm going slightly heavier now with a night tick. and heavier with that circle, which we want to see. Okay, so suddenly you should get a clearer idea now of what that product looks like. And I haven't had to rub out any of the other lines, they're very much in the background, but you can see that I've done my drawing correctly. The last thing that you have to do is then to transfer those measurements onto here, and we're going to be using something called leader lines, which almost touch your drawing but don't, but lead off your drawing. And then between those you're going to do arrows that have your dimensions written on them. And when you dimension up, so we've got nice little arrowheads like that. When you dimension up according to the real size. So we know that the height in the real size in 1:1 is 220. So we'd write on 220. Okay, so you need to dimension it up so that all of the information is shown on the product. You don't need to give that dimension again. So I've already told you the height's 220. You wouldn't have to dimension up that, but we don't know what the width is. The length is here, so we would need to put the length on. So you've got your little leader line, almost touching your drawing, but not quite. And then a nice little arrow between that with small arrowheads. And then that dimension was, for the length, 175. Okay, and you obviously would dimension that up separately, and we know that that's 20. Okay, so you put your real sizes on your drawing even though you've done it scale 1:2. Okay, hopefully that helps.